Okay, so this is number one, no? This is exercise number one. So will be our inputs. We'll mark in this block. Okay. And then our final output we'll put somewhere here. You just chat me if there's late, somebody's late, no? So I can. Yeah. Our output will be here. The first is A and B. So we need a two input and gate, right? Okay. Kailangan yata I'm not sure if we need a connector. Okay. But we need a two input and gate. Okay, A and B. So we'll connect this here. A and B. And then these are all OR together. So we will need a 1, 2, 3, 4 input OR gate. So we have a 4 input OR gate. Ito na. If you don't have a 4 input OR gate like this, no, you don't have a 4 input OR gate, you can make a configuration like this. Okay. So this is just like a 4 input OR gate. Do you follow? Everyone, no? So this and this are the same. Luckily, we have a 4 input on gate, or rather 4 input OR gate from Cedar Logic. So that saves us the. Now we can connect it here. Okay. The next is A not CD. Okay. So we'll have a 3 input AND gate. Okay, 3 input AND gate. Pwede pa ba ito? Hindi na pwede, no? Do you follow? So what we'll do is we'll make a connector. Okay. We need a connector for A. So where's a connector? Ito. This is a connector. We'll remove this first, no? Lagyan muna natin yung mga connectors. So you can couple connectors so you can make connections to several points, no? Una, ito muna para hindi tayo nahirapan, okay? Okay, and then we'll have another connector. Did you do this yourself? Okay. So dito natin i-connect yung B. Okay. And then we need A and B. So this will be A and B. Just move it here like that, okay? So that makes A and B. And then we need A, C, not C and D. So we'll use another connector here for C. Dito natin i-connect ang C. First, we are going to connect an A. So we need an A. Okay. And we need a NOT of C. Okay. So we need a this, something like this. Small inverter na lang tayo. Para mas maliit. Okay. Then remove this. We need a NOT of C, no? And then we need a D. We'll put a D here. Do you follow? We need a D, so we connect it here. That, and then remove. We save this first. Save. May save na natin sa iba, no? Ayaw niya eh. Wala siyang access doon. Ulang. Save. It's good to save from time to time, no? Of course, you know that, no? Cedar one. So we already have this, no? And then we need a CDE. Okay, so this is an AND gate. So this is a 3-input AND gate. So we look for a 3-input AND gate. Luckily, we have this. Okay, 3-input AND gate. We need a C, D, and D. So we have a C here. We have a D. And we have an E. I will get an E. Okay. Move na lang natin yung E, no? Okay, we'll move this a little bit like that, no? So it becomes clear. So what do we need? We need a C, D, E. We have a C, we have a D, and we have an E. So we use this. Okay, I hope it's clear, no? And then we need a B, C, D. So we need another basic gate, a 3-input AND gate, which is B, C, D. We connect a B here. That's okay. And then we connect as C. And then we connect a D. Wala na tayong D. We still have a D. Wala na tayong D, right? Putulin muna natin tong D. This is a C. Alam mo, bakit wala tayong D? We only have 3 for D. First, we have an A. This is an AB. Then we have a not CD. We have A not C. This is a not C. And a D. Okay. And then we'll have a CDE. This is a C. This is a D. And this is an E. So meron pa tayong isang ano, meron pa tayong isang B. Okay, meron pa isang D. So what we have is B, C, D. We have a B. We already have that B. Meron tayong B. And then we need a C. Saan ito galing? Let's delete this first. Itong D na to papunta dito. Right? Ayaw. So read this again. This is B, C, D, E muna eh. Okay. Erase muna natin to. Yeah, that's correct. This is a C. This is a D. C, D, E. And then what do we need is a B, C, D. We need a B. No, we already have a B. Okay, meron na tayong B. Then we need a C. If you run out of connector, you just connect another. No? Okay. Okay. And then we need a D. Okay. Is that correct? Now we connect this together. And then we connect it here. Okay. There's a waiting room, Sardinel. I'm sorry. I've just renewed my Zoom subscription. No? So hindi ko pa na-configure ng maayos. Kaya there's a waiting room. So now we'll have an Excel. blank cell. Ulitin na lang natin. A, B, C, D, E. Ganun na lang, okay? We have 0, 0, 0. This will be our Y. We have, oh, bakit ganun? 1, 2, 3, 4, 5. Y is a 0. Do you follow? Everyone? And then we need a 0, 0, 1. 1, 2, 3, 4, 5. Okay. So we will set this as 1. Tama pa tayo? CDE. Let's check the ano. I'm sorry na. That's our ano, expression. So isa lang yung E. Dito lang, okay? Now take note that the lines will go red, which means these are the lines that are activated every time you activate an input switch. Okay? And then we will have 0, 0, 0, 1, 0. Okay? So this will be okay. So what's the result? So both zeros. Then we will have, let's make a long story short, 0, 0. Pwede naman ganito eh. 1, 2, 3, 4, 5. Hanggang, ang 4 is 16. So this will be hanggang 32. Okay. And then we'll say equals depth to bin of this. Depth to bin. I think we'll have a put a 5. 5 na ba yan? 1, 2, 3. Yes, that's 5. Okay. Wala na, hanggang 0 to 31 lang tayo. Kulang pala tayo ng 0, no? Copy this. This is a 0. Okay. So we need a 0, 0, 1, 1. Did you do this? So this is a 1, 1. This is still a 0. 1, 0, 0. Still a 0. 1, 0, 1. Still a 0. 1, 1, 0. May 0 na that. May ano na. Then we'll have 1, 1, 1. This is 1, 1, 1. Okay. So now finally we have 1. Okay. Then we'll have 0, 1, 0, 0. 0, 1, 0, 0, 0. Okay, that's still a 0. 0, 1, 0, 1. 0, 1. No, sorry. Nagkamali tayo kanina. 0, 0 ito kanina. That's still a 0. And then we'll have 1. That's still a 0. Okay. Then 1, 0 is here. It's still a 0. Then 1, 0, 1, 1. We'll have it here. That's still a 0. Konti lang para, no? Okay. At unless you're making a mistake, no? 1, 0, 0. It's still a 0. 1, 0, 1 is a 0. Okay. 1, 1, 0. So this is a 1. Another 1. 1, 1, 1, 0. And then 1, 1, 1, 1. That's a 1. Okay. And then 1, 0, 0. So we have this. It's a 0. Okay. 1, 0, 1. This is 0. Then we'll have 1 0. This is a 1. Fortunately, we have another one. 1 1. It's another one. Okay. 1 0 0. That's a 0. 1 0 1. It's another 0. Oh, this is 0. 1 1 0. 1 1 1. That's a 1. So this is how you check, no? This is how you check your solution, whatever it is, no? This is how you can check your solution. So 1 1 0 0 0 is also a 1. Okay. Then we'll have a 1 1 0 0 1. It's also another 1. 1 1 0 1. Make this a 1 and this make this a 0. This is a 1. Okay. 1 0 1 1. This is also another 1. 1 1 0 0. It's also another 1. Then we'll have 1 1 0 1. So, and then we'll have 1 1 1 1 0. This is 1, this is 0. Okay, this is still a 1. Ang dami ng 1. And then finally we'll have 1. It's a 1. Okay. So now you know the mean terms. Do you follow? You know the mean terms ito. These are now the mean terms. You can now collect the mean terms and that you can now express it in SOP form. You also have the max terms. So you can now express this in POS form. Any questions, class? No? So did you do it this way? I haven't checked your attendance yet, your assignment yet, no? Okay. But take note, no? Kung ano yung mga linya na mag-red, it really become red, which means these are the ones that became ones. Like this is a 0. But still, this is an OR. So this will be a 1. Okay? Now, what I'd like you to do is an actual experiment. If you look at our, you can download our experiment manual. You can skip experiment number 1. It's no longer needed. Will you please download our experiment manual? So, laboratory manual. Can you please download this? This is a Word document. Okay, everyone. This is a Word document. Okay, let's look at the document. No? So this is the set of experiments that we will do. No? There are experiments that are difficult to do kasi walang circuits. No? There are no circuits in Cedar Logic. However, we can reveal them from scratch. No? Cedar Logic allows us to create a very large circuit because we can have up to page 10 pages of a circuit, and then we can connect one page to another using this from two connections. No? So you can connect one page to another from two. So from two. Sorry. Itong from and to. You can connect this from one page to another. So you can have a very large circuit distributed over 10 pages. Okay. So which means if there's no full adder, we can have a full adder here, and then we can just make a connection to the full adder. Okay. Any questions so far? No. So anyway, so the purpose of this is for you to do experiments on actual circuits so that we will not just be guessing, no, the circuits that we are going to build. The problem is, however, we cannot have an actual circuit anymore. So we cannot buy an IC. Kasi ganito yung dati, may mga IC tayo eh. No? We are going to use IC 74LS86. 08 is a quad input NOR inverter. No? 32 is OR gate. This is a NOT gate. No? NOT gate. Okay. And then XOR gate and NOR gate. I'm not sure if it's and or. You just Google this, okay? is sabihin naman dito eh, no? So this is experiment number 1. We skip experiment number 1 because experiment number 1 is just a part for you to familiarize, no, how to use an integrated circuit. If you buy an IC like this, an IC has the following pin configurations, no. It has a slot here. The slot means the topmost part, okay, and there are pins to the lower row and pins to the higher row. Now, it's always a convention that the last pin in the lower row is connected to the negative of your battery or your power supply. And the first pin of your higher row is connected to the positive 5 volts. Okay, you can watch this in the video, no? Which is in the topmost part of our Dayglar class. And you number the pins. So you start numbering from the lower row, from the left to the right, in the lower row. Okay, so which means you number 1, 2, 3, 4, 5, 6, 7. And then you continue by going back up. But this time you start from the right. Okay, so 8, 9, 10, 11, 12, 13, 14, the opposite way. So for a 74 LS, 08, I think, what's this? This is 74 LS08 pala. It's an AND gate, no? The AND gates are located inside. For example, pins 1, 2, and 3 compose an AND gate, with 1 and 2 being an input and 3 is an output. Okay, 4, 5, and 6 is also another AND gate. There are 4 AND gates inside the IC. No, 4, 4, and 5 are the input, 6 is the output. So 13 and 12 are the input, 11 is the output, 10 and 9 are inputs, and 8 is the output. Okay. And then you mount the IC, you interconnect them together. What we used to, ang ginagamit namin, we used to use the LAN cables in order to connect to the slot, to the breadboards. But we don't use that anymore, and you can do that if you like, no? You buy a breadboard, and then you buy the IC, and then buy a switch, a pin, and then buy a 5-volt power supply. You can have a 5-volt power supply, or you can use a battery. If this is their 5-volt battery, wala, no? So you buy a 5-volt power supply and then you connect. However, for experiment 2, we will do this in CDOR logic. An XNOR gate, we will use an XNOR gate. An XNOR gate basically can be used to compare whether 2 bits are equal or not. Why? This is the logic of an XNOR gate. 0 XNOR 0 is 1. Which means if both are zeros, it's 1, which means they are equal. If it's 0, 1, they're not equal, it's 0. If 1, 0, they're not equal, it's 0. If it's 1, 1, then it's 1, which means they are equal. So an XNOR gate is a word comparator. Okay, what I'd like you to do is to construct a 5-bit, rather a 4-bit word comparator, 2 words, no? Because 5-bit is a half a byte. Actually, you can buy a 74LX86, no? Which already, with a hex inverter, you already have a word comparator. Okay. So what you need to do is to actually mount this to lamps, no? And construct the truth table. Do you follow? Construct the truth table. Let's do that for A and B in Excel, no? Okay. Ito tayo, ito. Nandito, no? Ayun, nandito, no? We have A and B. This will be 0 to 15 because we have 4 bits each. Sorry. Mali na. Mali. I made a mistake in dragging this. Okay. Okay. Then we'll, the same time, no? We'll use that to bin. 4. Ang dami palang combinations dito, no? It's not just this and that, no? They follow? I just like you to pick the bits that are equal, okay? Kasi ito, i-compare mo is dito, then i-compare mo dyan, then i-compare mo doon. Do you follow? I just like you to correct the bits that are equal, okay? Not all of them. Okay? Kasi ang dami niyan. Okay? Only check the bits that are equal. Okay? So can I erase this now for the moment? What we'll do is to construct a word comparator. It's like this, no? So we have, this is A, this is B. Okay? So let's construct that in Cedar Logic. So first, we'll just need a text anyway, no? Decoration. We call this A3. A2. Baligtad tayo, no? A1. This is A0. I'll just start it, no? You finish the, no? You finish the whole circuit yourself, okay? You finish the actual test. You're going to do experiments 2 and 3 at the same time, no? Pass it next meeting. Class, experiments 2 and 3. You pass them next meeting, okay? We'll just copy this. Okay, and then put it here. And then we'll have this is B3. B2. This is B1. This is B0. So these are the bits which correspond to our truth table. Okay? So ito yung ating truth table, no? Do you follow? Ito yung ating truth table. This is longer because you have 16 by 16. Ang laki nito, no? Ang 16, i-compare mo by 16. But anyway, we'll just demonstrate. I'd like you to just look at the, ano, when they're equal, no? Collect when they're equal to find out if they're really equal. Okay? And then, we will make some connectors, input and output. This will be our A. Okay. And based on our experiment, we will need 4 XNOR gates. Okay? 4 XNOR gates. Any questions so far? Apat na XNOR gates. So experiments 3 and 4 by next meeting. I'm going to do upload the no, the assignment. Yeah. And next meeting we'll also introduce a new topic. No? 4 XNOR gates. Where will you get the gates? Dito, no? XNOR. We need this. This is an XNOR gate. Where's an XNOR? Do we have an XNOR? Ito. Do you follow? XNOR? Oh, XNOR nga. Because an XNOR is a word comparator. 4 XNOR gates. But we're just going horizontal, no? The actual figure written on the experiment is vertical, but they're just the same. And then after the XNOR gate, you will connect them together with an AND gate. AND gate ba? Yes, AND gate. No? You have to be careful in Cedar logic because there's something which looks like an AND gate. So this is not an AND gate, no? Okay. This is not an AND gate. No. This is the AND gate, no? 4 input AND gate. We put it here. And then we'll put an output. Okay, like that. So first, we need to compare A0 and B0, A3 and B3, no? So A3, this is a word comparator. We are going to compare A3 and B3. If they're equal, okay, this will result to 1. Take note, if I'll do it like that, no? Connect it here. So this is red. Do you follow? Which means A and B are equal. This is black, so A and B are not equal. Now, I'll make this, so this is red, so A and B are equal. So I'll make this one, so A and B are not equal. Do you follow? No, very self-explanatory, no? So ang ibig sabihin itong blue, you have missing connections. You have missing inputs, okay? And then we are going to connect A2 and B2. Pair them together. Okay. We are going to compare A1 and B1. Okay. We are going then finally we are going to compare A0 and B0. You follow? And then we're going to connect them together in AND gate. I'd like you to collect only the rows that are equal, okay? Do you follow? Any questions so far? Okay. So this is red, which means they are equal. Okay. If I'll put it like this, they're not equal. They are equal. Okay. This, they're not equal. This, they become equal. They follow? So this is a word comparator. You know, because in a programming language, especially in assembly language, no, you will have a conditional jump, and sometimes the conditional jump is based on whether two words are equal or not. No? Diba? Diba? And then to find out whether two words are equal or not, you need a word comparator. Okay, so this is a word comparator. This doesn't matter how many bits there are. This is only a 4-bit comparator. Okay. Any questions so far? Okay, so experiment number 4 is a word. 2 is a word comparator. What's experiment number 3? Experiment number 3 is a parity generator. It determines whether it's an even parity or an odd parity. We need a 4-bit XOR gate. Now, if you don't have a 4-bit XOR gate, you can do it this way. No, this is the same 4-bit XOR gate. Do you follow? Okay. But anyway, let's do that here. No? Let's do that here. We can have copy this. Right click, no? We'll Control C. Okay. Okay. We're going to have what? A 4-bit. Let's paste it here. Okay. 4-bit word comparator. No, it's a parity generator. We will determine whether it's even or odd parity. Okay. So an XOR gate is an odd parity generator, which means it determines whether the word is odd parity or not. Okay, so we have a 4 gate, 4 input XOR gate, XOR 3 input. We need a 4 input XOR. Do we have a 4-bit? This is a 3 input XOR. Ang dami na nito. 8 input. So, ito. Yeah, this is it. The 4 input XOR gate. If you don't have an XOR gate, 4 input XOR gate, remember, no? If you don't have a 4 input XOR gate, you can always make a 4 input XOR gate like this by using 3 XOR gates. It's the same story. Okay. So now let's connect this with an input. Then we'll connect an output. Okay. Now you can construct a truth table. Okay. We can always construct a truth table in Excel. Tanggalin na natin to. Okay. How many ones are there? Our value is 0, 0, 0. 0 is considered even. Okay. Let's put this one. Now, 0, 0, 0, 1. So now in our truth table, we'll put here. Okay. In our truth table here, we'll put a 0, 0, 0. We'll start with the 0. This is 0, right? Okay. Do you follow? And 0, 0, 0, 1. So this is a 1. So take note, why is it a parity generator? If the population or the count of ones is odd, it will generate a 1, which means it's a odd parity generator. How do we make an even parity generator? We'll just put a NOT. Okay. Let me label this. Okay. Then we'll copy this. Pangit yung pagka-copy niya, class. Kasi kailangan mong i-press yung ano. Pangit. Wala tayong magawa eh. Kailangan ganun. How do we make an even parity generator? We'll just put a NOT at the output. Okay. So where do we get a NOT gate? This one, okay. This is our odd parity. And this will be our even parity. You follow? Take note, no? For odd parity, no? Problema nitong ano? Hindi natin siya pwedeng, is the problem with ano? Mahirap i-shoot. For even parity, if you look at that, no? Ayan, i-ano na lang, i-unzoom na lang. Okay? You can unzoom using the mouse. So this is 1001. This is even parity, so the odd parity is 0. 101, 1001, it's even parity, so the even parity is 1. Okay? Let's try a 0, 0 first. Okay. So for this one, the odd parity is 0, the even parity is 1. Why is that? Because and the number 0 is considered to be even. Okay. Any questions so far? No. So 0, 0, 1. So we'll have a 0, 0, 1, 0, 0, 1. Okay. What's the odd parity? The odd parity is 1 here. The even parity is 0. Which means that the number of ones is odd. Now, at the bottom, since the number of ones is odd, the even parity is 0. Okay. Do you follow? For 0, 0, 1, 0, what do we expect? Ito yung 1. Ito yung 1. Okay. So what's the odd parity? The odd parity is 1. The even parity is 0. Do you follow? But what if you'll have 1, 1? Okay. 1, 1. How many ones are there? There are 2 ones. 2 is even. So therefore, the odd parity is, look at that, it's 0. It's 0. And the even parity is 1. Do you follow? So you pass this, experiments 2 and 3, the circuit and the truth table. Okay. So experiment 3 is word comparator. And experiment 4, you can just put them in 3 different pages, no? Just pass one circuit, no? 2 files, 1 circuit, and 1 truth table in Excel. Any questions so far? No? Individual na ito, no? Kasi madali lang naman, di ba? So you have experiments 2 and 3 to pass, and the next meeting we will introduce a new topic. Okay. Simple assignment. Okay. Sir, when it comes to checking po, ilahat po namin. Yung sa experiment 2, yung equal lang ha. Kasi kung experiment 2, ang haba niyan, no? Take note, no? In experiment 2, only the equal bits. Only the equal rows. So only. Hindi ka matatapos, no? 16 by 16. How much is 16 by 16? Okay. They follow. Now in experiment 3, show everything. No? Add an even parity. Okay. Okay. Do you follow? Files. Yes. So this is due on the 26th. At 12 o'clock. Ay, 12 pala, no? 10 na lang. Kasi anong klase natin? How many files? Saan yung files? Number of upload. Pwede na yan. Okay. Any questions? No? So, CDR logic. So, may applications tayo, no? Of course, in the experiment. Now, we will have, later, we will also have switches, no? Like MOOCs and demoocs. Multiplexers and encoders. No, this will encode. This is experiment number 4. We'll reserve that for next meeting. And experiment number 5, 7-segment display. Do we have a 7 segment display here? Meron tayo. 4, pero 4 bit. Okay? Let's try this, okay? On page 3. Ano mangyari, no? Let's go naka-switch. Decoded na ba ito? Is it decoded? Pass-through bus, ha? This is a decoded bit. Shall we connect? Eh, kung decoded, swerte. We are lucky. We don't have to build the decoder ourselves, no? Okay. Okay. So 0001. 1. Now it's decoded. Take note, it's decoded, no? 0010. Oh, that's 2. 0011. That's 3. We have a decoded, ano? We have a decoded 7-segment display. In fact, we have a 2-bit 7-segment display. Okay? May dalawa tayo. Oh. Kasi kung 111, hindi na niya kaya. Is that 15? 15 by F. Ang problema kaya sa decimal. No? F na kasi hindi niya kaya yon, diba? Sa decimal lang siya 6. 6. C. Ibig sabihin, that's 12. Kasi 8 plus 4. 1, 2, 4. So, is 8, 9, 10. Wala na siyang 10. Okay? Do you follow? This is hexadecimal. Okay. But anyway, hanggang 10 pwede siya. Wala ng 10 kasi 2 digits na eh. I think this will work, no? Ito, 7-segment display. So anyway, we will have that sometime. We're lucky because it's decoded, which means we don't have to build the decoder ourselves. Kasi next sana is binary decoder. How to decode how to decode a binary number to decimal. Okay? Pwede 'yon, no? And then do we have an encoder? Multiplexers na. Okay? We have multiplexers and then we'll have multiplexers ICs. Wala tayong IC sa ano, no? We have a half adder. Okay? We'll have, now we also don't have half adders in Cedar Logic. So we have to build the half adders ourselves. And then we have full adders. We will build a calculator, okay? A calculator which displays the result in decimal. Okay, decimal yung result, binary yung with binary input. Okay. Any questions? We will also build a subtractor. Pero hindi lang siguro 4-bit. 4-bit is too much for us because we don't have ICs, no? The problem with the Cedar Logic is we don't have ICs here. Walang integrated circuits. There's RAM. There are registers. There are flip-flops. But the ICs are very limited, oh. Meron siyang 3x8 decoder. We're lucky, no? We have a 3x8 decoder. So we can now decode this binary numbers. Okay, ang binary number na result, i-decode natin bago ilalagay sa, before putting on a 7-segment display. So we can build a calculator. Okay? We will not build a computer. Okay. We cannot build a computer here. Okay? Any questions so far? Okay. So that's enough for today now. Okay. So see you next meeting, everyone. Thanks for coming. Our exam next week, we will find out. Okay.
Thank you, sir.
Okay.
Bye,
Thank
sir.
you. Bye-bye.
Yes, sir.
Bye.